In this unit, you've been learning about the different types of bonds that hold the matter in creation together the way that we experience it all around us. You've learned about ionic bonds, covalent bonds, and metallic bonds as the three types of strong bonds holding matter together. You also learned that covalent bonds come in two different types that have very different properties, but the reason they're both covalent is because they both involve sharing pairs of electrons. In this lesson, we're going to put that knowledge that you have of how those different types of bonds form, we're going to put that knowledge to use in understanding something very practical about all matter in creation. Why matter tends to form different states at room temperature. Why some substances are solids that are tightly bonded with really high melting points. Why some form liquids, which are much more loosely bonded together than solids, but still have attraction between the molecules. And why some substances tend to form gases, which have very little attraction between the molecules in the gas. That's what we're going to be looking at as now we apply that knowledge of bonds that you've gained through this unit. Now, the first type of bond we're going to take a look at is perhaps the most straightforward. We're going to learn that ionic substances tend to form tightly bonded solid crystals at room temperature. Here I have a chromium ion. Chromium is a metal, and metals tend to lose extra electrons and form positively charged ions. Now, 6 electrons is a lot. So chromium actually has a very strong positive charge, strongly attracting negative ions all around it. So it's going to attract a substance that forms negative ions like a nonmetal, like oxygen. Oxygen tends to form ions with a 2- charge because it gains 2 electrons to fill its outer shell. Now, when you have this 2- charge tugging on positive ions in all directions, and that 6+ charge tugging on negative ions in all directions, this substance is going to bond together very, very tightly to make a crystal solid substance. Ionic substances, without exception, tend to form tightly bonded solids, and they generally have very high melting and boiling points. Do you understand why these substances form solids? It's because each individual unit of the substance, the ion, pulls very strongly on other ions in all directions. It pulls the substance together very tightly. It packs it together. It can't be anything but a solid. Now, these solid crystals do have melting points and boiling points. You can turn them to a liquid and a gas, but that doesn't happen unless you reach an extremely high temperature because the bonds holding these things together are so ridiculously tight. That's ionic substances, the easiest one to understand. The next one is also fairly easy to understand. Metallic substances also tend to form tightly bonded solids, and they also tend to have high melting and boiling points. Here's an example. Iron atoms come together, and they're going to stay nearby each other and bond pretty tightly together because they have all of these electrons in a sea of electrons between them. So these electrons are pulling on the cores of the atoms that are positively charged and sort of gluing them, holding them tightly together in a crystal arrangement. That's why metals tend to form solids. Here's the thing with metallic bonds. The more electrons that are shared in the sea of electrons that you see between these iron atoms holding them together, the more tightly held together the metal is going to be and the higher its melting point. The fewer electrons you have, the more loosely bonded the metal is going to be and the lower its melting and boiling point. However, the overwhelming majority of metals on the periodic table share enough electrons in the sea of electrons that's holding and pulling and tugging the metal atoms together. They share enough electrons to say that in general metallic substances have very high melting and boiling points. Another type of substance that's important to understand is a polar covalent substance. Now remember, polar covalent substances are substances that share electrons in pairs between atoms, but they share them unevenly. So there's going to be positive places around the molecule and negative places around the molecule, and those sticky spots are going to attract other molecules' sticky spots. So here we have the positive and negative spots on a formaldehyde molecule attracting other positive and negative spots on other formaldehyde molecules, which is going to cause them to bond together slightly. Now for formaldehyde, the molecules are going to come together and bond so weakly that it actually makes a liquid at room temperature. Sometimes this dipole bond between molecules, those positive and negative sticky spots around the outside, they bond so strongly just because the molecules are arranged so that they can bond more tightly. They bond so strongly that they can form a solid at room temperature. That's what sugar does. Sugar makes a solid at room temperature just because of the positive and negative sticky dipoles around the outside allow it to bond together tightly enough to be a solid. And there are even some polar substances that just don't have strong enough dipole bonds, and they actually are gases at room temperature. And it all has to do with the strength of the bonds holding the molecules together. Now, hopefully at this point you're understanding that when you think of these different substances, it's the strength of the attraction between the smallest unit, between ions, between atoms of metals, or in this case, between these polar molecules. It's the strength of attraction between these units that causes them to pull together as solids, sort of pull together as liquids as the molecules slide past each other, or not pull together at all and remain gases. And that's what this last type of bond typically causes to happen. Nonpolar covalent substances are usually gases at room temperature. And here's why. With a nonpolar covalent substance, you don't have positive and negative sticky spots around the outside of the molecule. They share electrons very evenly. And because of that, there's nothing that strongly attracts one molecule to another molecule. There's no real reason for them to stick tightly together to make liquids or solids. However, there is one type of bond that throws a wrench in the works and makes nonpolar covalent substances very difficult sometimes to figure out, and that is the dispersion bond. How in larger atoms and molecules that have a lot of electrons around the outside, those electrons can sort of move to one side of the molecule and form a temporary negative charge on that side and a positive charge on the other. And that negative charge will push on the electrons of another nearby molecule, which will form the exact same temporary weak dipole. And that happens with a bunch of molecules all around, causing molecules that really have no reason to stick together to have a reason to stick together. And this sometimes can cause nonpolar covalent substances to form solids and sometimes liquids. So even nonpolar covalent molecules, even though they really don't have a good reason to bond to other molecules around them, do have this type of bond that allows them to stick together as a liquid or a solid. However, most nonpolar covalent substances will be gases at room temperature, possibly liquids, and in rare cases, they're solids. So hopefully at this point you have a really good understanding about how the different types of bonds affect the states of matter that we observe in nature all around us. Ionic bonds form tightly bonded solids. Metallic bonds tend to also form solids. For both of those, it's because the atoms or ions are really strongly pulled together by the type of bond holding the atoms together. Then following those two types, polar covalent substances tend to form solids, maybe liquids at room temperature, because those dipoles can be very attracted to each other as well, which will strongly pull molecules together. And then finally, the weakest type of attraction occurs between nonpolar covalent substances, which tend to have very low melting and boiling points. The only thing that can really ever hold those substances together are those extremely weak dispersion forces that will sometimes hold substances together as solids, but can only do so with a very low melting, and boiling point.